Okay, gang. Well, now that you have DS9, you're going to want to see how to use it. Next week, we will have an in-depth tutorial on all of the things that DS9 can do, but I thought it would be interesting for you to finish out this week with just a general broad overview about the structure of the software and some of the neat things that you can actually do with it. So let's go over to our screen and see what DS9 is up to. We open DS9, and usually the first thing that you're going to want to do is go to this menu bar here, and under Analysis, you're going to scroll down and click on the Virtual Observatory. This will bring up a window that allows you to connect to the hundreds and hundreds of observations that Chandra has made over the years. Attention! Newsflash! We interrupt this broadcast to bring you a special bulletin. DS9's Virtual Observatory needs to have a parameter set in order to function properly. It's easy, and here's how to do it for both Mac and Windows systems. If you have a Macintosh, this is what you do. When you start DS9, you go to Analysis, click on the Virtual Observatory, and before you check Rutgers Primary MOOC X-ray Analysis Server, just make sure that this radio button here that says Connect to VO servers through the remote web server is initialized. When you do that, DS9 will function properly. If you don't want to do that every single time you initialize DS9, every single time you use it, you can change in your preferences a parameter that allows you to do it automatically, and you don't have to worry about it anymore. The way you do it is as follows. You go to SAO Image DS9 on your top menu bar and click on Preferences. When you do that, you will see a dialog box, and one of the possibilities under Preferences is VO, Virtual Observatory. Click on that. When you click on that, you can then enable your Connect using Web Proxy radio button over here, and after you click right there, you will then be able to save it. That's it. For a Windows machine, it's almost identical. You go to Analysis, click on Virtual Observatory, then you get your dialog box, and before you click on Rutgers Primary MOOC X-ray Analysis Server, make sure that you click on this radio button that says Connect using Web Proxy. If you don't want to do that every single time you start DS9 for this course, you can change the parameter in your preferences so it will do that automatically. The way you do that is by going to Edit, Preferences, and when you do that and click on it, you will see a Preferences dialog box, and you can select VO for Virtual Observatory. When you do that, you'll get another box, and you just make sure that this little radio button here that says Connect using Web Proxy is enabled. You save it, and you're done. That's it. And now, back to our regular programming. First thing you're going to do is connect to the Rutgers Primary MOOC X-ray Analysis Server. Make sure that you click on this radio button that says Connect using Web Proxy. And when you do that, you will get another screen that now lists all of these observations. Let me kind of position things so we can see everything usefully. And here is a listing of hundreds and hundreds of observations that have been made with the satellite. And in order to see what some of these things look like, we're going to click on the first one, ACIS observation of Cas A. Now you see immediately an image is loaded into our viewing area, and we can, for instance, change its color by selecting different color schemes and doing all sorts of interesting kinds of displays in that way. Also, we can change something that's called the scale. I'm going to select the square root scale, and we'll talk about that next week. But you can see that this display now changes, and you can look at this particular object, which is a supernova remnant, in its entirety. Notice that as I cruise around with my pointer, lots of things are changing in the informational area at near the top left of your window. You see something called alpha and delta, which is the position in the sky, and you also see the actual pixel that is being looked at or pointed to, and you can see that more clearly in a magnification box that is at the upper right-hand corner of your main window. Also, what you'll see as we cruise around is the value of the intensity at the particular point that the arrow is looking at, and you can see that value change as I go from one place in the supernova remnant to another. Now, it's hard to select a particular point using the mouse. Things kind of jump around a little bit. But what you can do is, for instance, we can click setting down a region here, and we'll talk about regions, and that's going to be the area in the object that you're actually going to examine the data for. And if you click again after clicking once, you can see that now you have selected that region, and there's 4 little handles on the region that allow you to change or position that region wherever you want, and you can go up or down 1 pixel at a time by just using your up and down arrows on your keyboard. So notice what happens in the informational box when we do this. The value changes, meaning the brightness of the supernova is changing as we look at different parts of it. You can see in the magnification box what we're actually looking at magnified, so you actually can see the pixel structure. You can see the position in the sky is changing, it's alpha and delta, and the actual pixel number that identifies where we are in the actual photograph or image also changes. So you can use your up and down arrows, left and right, to move 1 pixel at a time. Now, if you accidentally put down a region that you want to get rid of, all you have to do is select that region by clicking again within it and hitting the delete key. And then boom, the region is gone. And you can still pan up and down. And now notice here, this is interesting, this little tiny, tiny white dot, almost 1 pixel in size, actually a couple of pixels in size, but definitely tiny. And geez, it looks really close to what might be the center of this object. We're going to have more to say about that as time goes on. But now, in order to see what the values of the brightnesses are in the region surrounding where you're pointing, you can actually go to View and have the horizontal and vertical parts of the image explicitly shown to you. And here I'm going to lift this up a little bit. This is going to be a little tricky because my screen is a little bit too small for this, but I think you can see what's going to happen. Watch what happens when I go back into the area that is denoted by the supernova remnant. I can, for instance, set down a region and go back and forth and look at a slice through the supernova remnant, both vertically and horizontally, as things change as I move 1 pixel at a time. So let's go back to this central point here. And now, in order to see what the actual values are of the region surrounding it, let's go to Analysis and look at the pixel table. If I drag that pixel table over to here, you can see now that you get a little box which gives you, along the top and left side of that box, the actual image pixel numbers, and you can actually, if you want, go back and forth by 1 pixel at a time to see what the intensity of the supernova is, in this particular case, very close to the center of the remnant. Let's see how close it really is to the center. We'll just grab one of these little handles here and drag our region out to make it bigger. Boy, it really does look pretty close to being in the very center of this big blob in the sky. But there's some other stuff, like what's going on here? That doesn't look like it's part of some kind of spherically symmetric object. So these are all things that we will explore in the future, and this gives you at least some idea about what can be done using DS9. To look at another source, let's do the following. First, let's get rid of our pixel table. And let's also get rid of our horizontal graph and our vertical graph. Bring this back down a little bit. And now let's load a different observation. What we're going to do here is, instead of looking at Cas A, we're going to look at another supernova remnant called Tycho. And we'll load Tycho into our observation box here. And color will, I guess, leave it HE. And scale, well, let's see what it looks like. That looks pretty good. Okay, now notice there are these kind of like gaps in the data over here. And that is actually a reflection of the chips in the Chandra satellite and the fact that these chips are located side by side, and there are some parts of the sky then that fall between the chips. So sometimes you'll see these X types of patterns that really don't mean anything as far as the actual X-ray source is concerned. But now I want to show you something interesting. Let's go back to analysis, and now we're going to look at an image server. This is a set of data that actually consists of other types of optical or radio images of the same area in the sky. So if, for instance, we scroll down to NRAO NVSS and click on that, what we end up with is another little window, and it will now allow us to retrieve that part of the sky that corresponds to the alpha and delta, or the position coordinates, of the Tycho supernova remnant. So if we click on retrieve, you now see a little box that is the radio image of the exact same part of the sky as we see here on the left. So what I'm going to do here, we can do something even neater than just displaying it. I'm going to click on this left frame, which is our original X-ray image. And now if I go to frames and scroll down to match frames, and I click on WCS, which is World Coordinate System, boom! Look at what happened to our radio image. It got slightly larger, and it got slightly larger in exact proportion to the size of the X-ray image. So now we are seeing the exact same areas in the sky at exactly the same magnification. Now we can do something that's even more interesting. And that is, if we go to Edit and change our pointer to a crosshair, now we have a set of crosshairs that can link up the radio image over here with the X-ray image over here, and we can lock the two together. So if we go to Frame, Lock, Crosshairs, now we can cruise around one of those images, picking out a region, say, here in the X-rays, and seeing exactly what corresponds to that part of the image in X-rays in the radio regime. So you can cruise around the entire area and select out regions of the sky that might be of interest to you. Now, one of the things you'll notice right away here is that this radio image looks blurry. It's not really blurry. It's just the fact that radio waves have much longer wavelengths than X-rays, and because of this, it's just a fact of life that you don't get the same types of resolution for your images. Things don't look quite as good in some radio images as they might look in some X-ray images. But radio astronomers have a lot of tricks up their sleeves, and they can use interferometry to make these radio images appear very, very pristine and accurate indeed. So this is really our first cut at what DS9 can do, and I hope you will use DS9 on your own, and starting next week, we will have an in-depth tutorial about what this really nifty piece of software can do for us. So we'll see you then.